All right. Uh, so, uh, uh, so we have seen there that 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 material particles can behave like waves, and which was hypothesized by de Broglie, and it was experimentally confirmed by Davison and Germer experiment that that electrons can behave like waves. Now, for the further confirmation of wave nature of material particles, double slit experiment was conducted, and this experiment further supported the fact that material particles, probably the microscopic material particles, have waves associated with them. Now, if I rightly go back to the double slit experiment for light, we understand that when we allow the light, a monochromatic light, to fall on two slits, provided the width of the slits that we have in the experiment is of the order of wavelength of light used. So in that case, we find a pattern of fringes on the screen, and the pattern of those fringes can only be explained by assuming that the light is behaving as wave. So it is redistribution of energy that takes place when you have wavelets coming out of these slits. When these wavelets come out of these slits, they can interfere constructively and destructively, and we will have a final pattern on the screen with dark, bright, dark, bright, dark, bright fringes. So in order to explain the validity of a dark fringe, we say it is because of destructive interference that's taken place between the two wavelets. And similarly, for the bright fringes, we say that there is constructive interference between the wavelets taking place that leads to the bright fringe on the screen. Now, if we replace the source of the same experiment, now instead of using light, if we use a beam of electrons, a highly collimated beam of electrons, when we do that, and we maintain certain decorum of the experiment, where it is essential that the experiment should be taken place in a highly evacuated chamber. When we repeat the experiment for electrons, so in this case, we have a source which is a source of electrons, an electron gun probably. This electron gun emits electrons, and these electrons go through the slits of the experiment. And what we observe, now what is the necessary condition for the same experiment is that the order of the width of the slits should have magnitude close to the wavelength that the matter waves have. So what happens, what probably is observed in this experiment, if you can see on the board, you have an electron gun, and from this electron gun, a highly collimated beam of electrons is generated. These electrons are bombarded on this plate, where you have two slits. You can call this slit 1, slit 2. And what is observed on the screen is the pattern. You are observing a pattern of I should say in simple words here, fringes, where you have maxima, minima, maxima, minima, maxima, minima. So if electrons are actually particles, then such kind of observation is impossible. We cannot have the pattern that we observe on the screen. So this pattern that is obtained on the screen can only be explained by assuming that electrons are behaving as waves, and it must be because of those necessary conditions that were true for light. So wherever you find a maxima, that must probably be by virtue of constructive interference of the waves, and wherever we obtain the minima in the pattern, that must be assigned to the destructive interference of waves taking place. So the conclusion of this experiment is that these microscopic particles like electrons, they behave like waves under certain circumstances. So the pattern that's obtained in this experiment is visualized using an electron microscope. So here we realize the fact that what de Broglie predicted, there are two supports of experiments that support the wave nature of material particles. One is Davison-German experiment. The other one is the double slit experiment, in which the source of light is replaced by beam of electrons.